So in this video, I'm going to go through a few examples on how to find the area under the curve. In this case, I want to find the blue area. So I have this curve, okay? So the first thing to do, I'm going to expand it first so it's easier to see in that way. I'm going to get negative x squared plus 2x plus 3. And I'm going to integrate this. So I have something like this. So I'm going to find the area. So we have 3 to 0. And then I'm going to integrate. So I'm going to copy down the equation first. Okay, so you're going to get this, and when you integrate, you will get something like this. Okay, and 3 and 0. So we're going to substitute 3 inside and then 0 inside. That will get me negative 9 plus 9 plus 9. After I substituting 3 inside, minus 0, because you sub in 0, everything will become 0. And you get your 9 units square. So that's for the first one. And now we move on to the second example. As you can see that we now want to find 3 different parts of this shaded area. So we can do it separately, but first we need to know what is the x coordinate for the intersection between the curve and the x-axis. So we're going to factorize this, and when you factorize out, you have x minus 2, x minus 4, and we're going to let it be equal to 0. That will get me 2 and 4. Right, so we now want to find the area. So we're going to find the area above the x-axis. That will give me a positive value. So we have to integrate 6 to 4. So 6 to 4. So I'm going to put it down. So we have something like this, dx. So when you integrate this, you will have something like 6 and 4, right? So we have x3 over 2 minus 6x squared over 2 plus 8x. So that will get me the area for this region. So we have this one, right? And so you substitute 6 inside minus the substitution of 4 inside, you get that area. Now we want to find the other one here. So we're going to find this area here. So to find this area here, so I'm going to do it above there. So we have the same thing, but right now it's 2 to 0. So you put in the same value, x squared minus 6x plus 8 dx, and that will get me the same thing, x3 over 3 minus 6x squared over 2 plus 8x, but right now it's going to be 2 and 0. Okay, so it's a little bit messy here. I'm going to erase this. Okay, so then you do the same thing, you get that area. And the one below here, the one right down here, is almost the same as doing this for 2, integrating with your dx. But this will get you a negative value. So remember, you need to mod it. You got to modulus it. Okay, so you'll get into the same thing as x cubed minus square. So we have something like this. But in this case, because you know that you're going to get a negative value, you can mod it first. And then you just add on the ones you find for the different parts of the area. Add them together, you get the area for the answer there. For the next question, we want to find the area of the blue region. And right now is that if you can see that we have to integrate with respect to my y-axis, because I'm gonna erase the blue region first. We're still gonna find that, but if you're gonna integrate my y equal to x squared, you're gonna get this red region here. Everything under that, y equal to x squared. Then we're going to minus away from, we're going to find this green region, which is under the y equal to 4x squared. So we're going to find the red region minus the green region. That will get me the blue region back. So we're going to do that. So we're going to integrate my y equal to x squared. But before that, because we are integrating with respect to my y-axis, we got to make x the subject for both of them. So we're going to get this for the one above there, x equal to half square root y, and this will get me x equal to square root y. It's very important to do that. If you don't do that, you got it wrong. Okay, now we're going to integrate them. We're going to integrate the x equal to square root y first to get the total area. So the integration is going to be 4 and 1, right? The higher number against the smaller number. So you're going to integrate square root y over dy, and then after that we're going to minus away my integration of 4 and 1 also of my half square root y dy, and you're going to manipulate this and you will get the answer for the blue shaded region. Okay, for the next type of question, we want to find this area, the shaded region. We are given with two different equations. The first thing to do is to find the intersection for the point. So to do that, we just have to equate them together. And then you are going to solve this. Find x. You find that x is equal to 0 and x equal to 3. This means that here this is 3. So what are we going to do? If you look closely to find the blue region, I'm going to erase it first. And then let's say you want to find the region of the red one, which is under the curve or under the equation of y equal to x open bracket 9 minus x, right? And then after that, we're going to deduct away the green region, which is under y equal to 2x squared. And then will get me the blue region just now, right? You'll get this one. And that is all you need to do to integrate them. And is it with respect to my x-axis? Yes, so I do not need to make x the subject. So we're going to integrate. So to find the blue region, we're going to find the red region minus the green region. So we're going to integrate 3, 0, my x, 9 minus x, okay, dx. And then going to minus away, same thing, 3, 0. But now it's a different curve. I'm going to minus away the green region. So we have something like this, and if you're going to solve this, you get the answer. For this example, you can see that we want to find the area under the above the y-axis. So it's with respect to the y-axis. So the first thing you're going to do is to convert this equation into x equal to something, and that will get you 1 over y plus 1. And then you're going to integrate so that you can get the area. It's from 4 to 2, and we have 1 over y plus 1 dy. Then you solve it. You can put the integrated form here. 1 over y will be ln y plus y, and then you're going to substitute inside. You get ln 4 plus 4. So this is the first set, minus ln 2 plus 2. You're going to solve this, you get ln 4 over 2 plus 2, and that will get you ln 2 plus 2, and whole thing unit square. So for this example, the first step normally when you do integration for area under the curve is to think about how you're going to get around it and find the shaded region. Because if you have no problem with integration, the methods to do integration, then you just have to worry about how you're going to find the area. So for this case, we have the blue area. You can pause the video, go ahead and think about how you're going to do this. So to do this, what we're going to do is that, let's say we want to find the blue region. What I can do is to find the area from here. So the first step is to find what is this x and what is this x. I want to find the area under the curve from this point. So I'm going to color red from everything from here, everything from there under this curve. It goes all the way down forever, right? So then the next thing that we're going to do is that we're going to find the area under the line. So we're going to find the area under the line. So to do that, we let it be green. So we're going to find the area under the line. So you can see that if I use my red region minus the green region, I'll get the blue, right? So what we're going to do is that first you got to do simultaneous equation, find the x coordinate. So when you find the x coordinate, you get that this point is going to be 1, this is going to be 1, and this is going to be your -2. Okay, so with that, we can just integrate and find the blue region. So we're going to integrate the curve first. So this is with respect to my x-axis. So in that case, I have my area to be. So I'm going to do a bit of shortcut. So in this case, we're going to integrate 1 minus x squared first. So when we integrate 1 minus x squared, we get x minus x3 over 3. Okay, and then you just have to put in 1 and -2 there. And we're going to minus, deduct away from, same thing, 1 and -2, but this time round it's a line. So it will be x squared over 2 minus x. Okay, and there you go, you get the answer once you substitute inside the values, and you get the area of this blue region. So for the last example, you have this, you want to find the blue shaded region. You can see clearly that it's respect to the y-axis. This means I need to make x the subject, and that will get me this. And when you integrate, by now you should know that it will be 3, 0. You can bring out the constant 1 over 3 and go ahead and just integrate this, right? And once you're done with that, you'll get the answer.